So, let's dive right in. We're on a quest today to answer what sounds like a simple question, but is actually one of the trickiest in all of tech. What is artificial intelligence, really?
And just to get a sense of the stakes here, listen to this from AI expert Kai-Fu Lee. He says its impact will be more than anything in the history of mankind. I mean, that's not just a big deal. That's everything. So we're talking about something huge.
But for something that's supposed to change the world, it's kind of weird that nobody seems to agree on what it actually is. We hear AI thrown around all the time, right? But it turns out even the people building it have different ideas.
And here's the thing, there is no single one-sentence definition. But that's okay, because what researchers do have is a really useful framework that helps make sense of the whole field. It basically breaks everything down into 4 different goals, 4 different visions for what an intelligent machine should be.
You can think of this framework as our map for this explainer. It's how the experts themselves navigate all the different philosophies and goals behind AI. So let's take a look at how this map is laid out.
Okay, so this looks a little academic, but it's actually super simple. The whole field of AI can be organized along 2 questions. First, on the vertical axis, are we trying to mimic humans, flaws and all, or are we trying to build something perfectly logical and rational? And then the second question, on the horizontal axis, are we focused on the internal process, the thinking, or are we focused on the external result, the acting? These 2 questions give us our 4 quadrants.
All right, map in hand, it's time to start exploring. We're going to jump into each of these 4 boxes, one by one, and see what each of these visions of intelligence is all about.
First up, acting humanly. You can think of this as the imitator approach. The goal here isn't necessarily to build a true thinking machine, but to build something that's just so good at faking it that you can't tell it's a machine at all. And the ultimate test for this, of course, is the famous Turing test. You know the one. Can a machine have a text conversation with you that's so convincing you can't tell if you're chatting with a person or a piece of software?
Now, to pass what's called the total Turing test, which involves seeing and touching things, a machine would need to have the whole shebang. It needs to understand language, obviously. It needs a way to store knowledge. It needs to reason with that knowledge and learn new things. And on top of that, it needs to see with computer vision and move around with robotics. I mean, that's basically a checklist for the entire field of AI. It's a massive, massive challenge.
But here's where things get interesting. This is a brilliant analogy for why most researchers actually moved away from the Turing test. Think about it. We didn't learn to fly by building machines that flap their wings like birds. We succeeded when we stopped imitating birds and started understanding the underlying principles of aerodynamics. The same logic applies to AI. Maybe the goal shouldn't be to imitate us, but to understand intelligence itself.
And that idea, that leads us perfectly to our second quadrant, thinking humanly. Let's call this the mind mapper approach. This isn't about just faking it anymore. This is about trying to actually build a model of how the human brain really works, with all its weird quirks and shortcuts.
So how on earth do you even begin to do that? Well, this is where AI and cognitive science team up. They use a few different methods. You can try to catch your own thoughts as they happen. That's introspection. You can run psychological experiments to see how other people solve problems, or you can literally watch the brain in action using things like fMRI scans.
Now, this sets up a really critical distinction. The thinking humanly approach is all about modeling how we actually think. But what if the goal isn't to be human, but to be perfectly correct, to be logical? That brings us to the other side of our map.
Welcome to Thinking Rationally, the world of the logician. The goal here is totally different. It's about building systems that operate on pure, undeniable logic. It's about trying to figure out the laws of thought, the rules for thinking correctly.
And this idea is an old one. I mean, it goes all the way back to the ancient Greeks, to Aristotle. It's this long historic quest to build systems that work like a mathematical proof, where the conclusions are guaranteed to be true if the starting points are true.
And the classic textbook example is this one, right? All men are mortal, Socrates is a man, therefore Socrates is mortal. It's clean, it's perfect, it's a structure for reasoning that is always, always correct. That's the dream of the logician.
Which brings us to our 4th and final quadrant, acting rationally. Let's call this one the optimizer. This approach makes a subtle but really important shift. It says, you know what, maybe it's not about right thinking, maybe it's about right doing. It's about taking the best action to achieve a goal out in the world.
The key idea here is something called a rational agent. And an agent is just anything that can look at its environment, figure out what's going on, and then take an action to get the best possible result. And crucially, it can do this even when it doesn't have all the information, when there's uncertainty.
Okay, so we've got our 4 contenders: the imitator, the mind mapper, the logician, and the optimizer. But in the modern world of AI, one of these has pretty clearly become the dominant approach. So which one won? And, more importantly, why?
The rational agent approach, the optimizer, won out for 2 big reasons. First, it's just more general. Perfect logic is great, but it's only one tool an agent can use to act rationally. Sometimes a good guess is the rational thing to do. And second, it's just more scientific. Rationality is something you can define with math and test with experiments. Thinking like a human? That's a lot fuzzier.
In fact, this approach is so popular, it's now known as the standard model of AI. The whole game is about building agents that do the right thing. And the right thing is defined by whatever goal or objective we humans give them. This idea is so powerful, it connects AI to all sorts of other fields, like economics and statistics.
But, and this is a huge but, the story doesn't stop there. Because as powerful as this standard model is, it has a major blind spot when it bumps up against the real world.
Here's the problem. The standard model works perfectly if we can give the AI a perfect objective, like win the game of chess. The rules are clear, the goal is clear. But in the real world, how do you write a perfect objective for something like be a helpful assistant or drive a car safely? It's incredibly difficult, maybe even impossible, to specify that goal without leaving some dangerous loophole.
And that's really the final thought I want to leave you with. The entire standard approach to AI is about building powerful optimizers that achieve a goal we give them. But that forces us to confront a really deep, really important question. In our messy, complicated world, who gets to write the objective? It's a question we're all going to have to figure out an answer to. Thanks for joining me on this one.